Okay, so number 66 states that astronauts use a centrifuge to simulate the acceleration of a rocket launch. The centrifuge takes 30 seconds to speed up from rest to its top speed of 1 rotation every 1.3 seconds. The astronaut is strapped into a seat 6.0 meters from the axis. A. What is the astronaut's tangential acceleration during the first 30 seconds? And B. How many g's of acceleration does the astronaut experience when the device is rotating at top speed? Each 9.8 meters per second squared of acceleration is 1 g. So this situation looks a bit like this. So we have our centrifuge, which is probably a bit bigger than this actual circle I have here. And we have our astronaut strapped r away from the axis. R is equal to 6.0 meters. And we have a bit of labeling here. So for A, we're going to be finding tangential acceleration, AT, using angular velocity and the radius and time. On this little diagram I have here, I have R and angular velocity as well as acceleration, tangential acceleration. And then for B, to find how many g's of acceleration is felt, we're going to need the angular velocity, the radius, and centripetal acceleration, which is equal to this vector going in at a right angle from velocity. So we're going to move these up a little bit so we can have them for reference later. So for part A, what is the astronaut's tangential acceleration during the first 30 seconds? So we want the tangential acceleration from t equals 0 to t equals 30. So we know that AT is equal to radius times angular acceleration. And angular acceleration is just the change of angular velocity over the change of time. So we need to find the angular velocity. And so the angular velocity final at 30 seconds, which is the final part of this situation, is equal to 1 rotation multiplied by 2 pi radians over 1.3 seconds. And we get 4.833 radians per second, and that's angular velocity final. Now, angular acceleration can also be found using this equation here. Angular velocity final is equal to angular velocity initial plus angular acceleration times time. And we're just going to rearrange this and solve for angular acceleration. So we plug in what we know, and we know that angular velocity initial is 0 because there's no velocity at time 0. And so we do a little bit of math here, and we get angular acceleration is equal to 0.1611. And so we're just going to plug that back into our equation up here for tangential acceleration, and we get 0.9667 meters per second squared. Now for B, how many g's does this astronaut experience? So you know how you're on a roller coaster and you feel like a force driving you in a certain direction? That's the g's you're feeling from the roller coaster. Or if you were swung around when you were a child, like by a parent or a guardian or a big brother who just really wanted to torment you all the time, what you felt was the g's. And so we need the centripetal acceleration for this part, as I stated above here. And so we can find centripetal acceleration, AR, by squaring the angular velocity and multiplying that by the radius. And so we're just going to plug in what we know, and we're going to get centripetal acceleration is equal to 140.16 meters per second squared. And we're going to divide that by 9.8 meters per second squared, as stated above here. And we're going to get 14.30 g's. And so our learning goals for this question were to practice uniform and non-uniform circular motion and what to do in finding different components of this motion. Thank you very much, and I hope you have a lovely day.